5 powers combined, they summon Earth's greatest champion, Captain Planet. The power is yours!
Everyone knows that Captain Planet loves lakes. What people don't know is that he knows a whole lot about them too. Let's join our captain as he guides us through a paper authored by S.C. Maberly about inorganic carbon species in a freshwater ecosystem. Dissolved inorganic carbon, or DIC, plays an integral role in the functioning of aquatic ecosystems. DIC buffers waters against rapid changes in pH, determines the amount of inorganic carbon available for photosynthesis, and removes inorganic carbon from the water column via precipitation as calcium carbonate. Let's take a look at how the buffering system actually works. Carbon dioxide that enters the water through various sources can dissolve and react with water molecules to yield carbonic acid. This is a weak acid which dissociates into bicarbonate. Under most natural conditions, bicarbonate is the most abundant form of inorganic carbon. If the substrate is rich in carbonates and CO2 levels are high enough, the protons produced will dissolve the carbonate rocks and release calcium and bicarbonate ions into the water. Bicarbonate can further dissociate into carbonate, which, at high pH, is readily precipitated after further withdrawal of CO2. The key feature of this process is that if the equilibrium between the different forms of inorganic carbon changes, then the reaction will shift one way or the other to re-establish equilibrium. This process is very important biologically in lakes and allows organisms to survive without experiencing large fluctuations in pH that could potentially be fatal. The paper by S.C. Maberly that we will be discussing examines diel, episodic, and seasonal changes in pH, as well as changes in the concentrations of inorganic carbon in a productive lake. To collect data on these cycles, Maberly placed pH electrodes and a thermistor on the surface of Esthwaite Water, a small lake in the United Kingdom. These instruments gathered pH and temperature readings from the surface water every 15 minutes for a 1-year period. Seasonal temperature and pH changes were significant. pH ranged from 7.08 in October to 10.27 in August. Temperature was found to be positively correlated with pH. This is because increased temperature and sunlight reduces the solubility of CO2 and increases the removal of CO2 via photosynthesis. In the fall, overturn was thought to have mixed inorganic carbon that was trapped in the hypolimnion, or the lower part of the water column, into the epilimnion, the upper part of the water column. This resulted in a decrease in pH. Throughout the year, bicarbonate was the major form of inorganic carbon. This was due to the large range of pH. However, high pH caused by high production and temperatures in August led carbonate to comprise 44% of the total inorganic carbon pool. pH remained consistently high during the summer months due to stratification. Stratification creates a better light environment for phytoplankton that are no longer being mixed into deeper and darker waters, inhibits the exchange of inorganic carbon between the hypolimnion and epilimnion, and warms the surface waters. pH and inorganic carbon species vary from day to day as physical and chemical factors disturb equilibrium. These changes were most extreme during the summer months. During the summer, when photosynthesis was at its maximum, inorganic carbon concentration was observed to decrease rapidly during the morning and remain low throughout the day, before increasing again after dark. It was also found that changes were not attributed to CO2 in the summer, but rather to bicarbonate and carbonate. Inorganic carbon and the pH of the lake could also change episodically. These episodes include changes in wind velocity, low pressure systems, rainfall, and sunshine. These all have somewhat of an indirect effect. Increased wind velocity is usually associated with low pressure systems and rain, which increase the mixing of the water column and diffusion with the atmosphere, all of which can decrease the pH and alter the species of inorganic carbon present, while sunshine can temporarily increase primary production and temperature and increase the pH. So what were the conclusions? The study found that inorganic carbon plays a major role in aquatic ecosystems by creating a buffer against large fluctuations of pH that could otherwise be catastrophic to aquatic life. It also found that the proportions of different species of inorganic carbon do not change drastically over long time scales, such as the seasons. Bicarbonate is generally the most abundant. Daily, the pH and concentration of inorganic can vary, the extent of which depends on the season.